All right, welcome to Statistics. We are going to start our notes with a lot of vocabulary. So that's new to you in a math class, but we have a lot of vocab to cover in statistics. So here we go. Some key terms you need to know. Obviously, statistics, what is it? It's the science of planning and studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on that data, right? Correctly using data, basically, is what it is. Now, collection of observations that we find are what we call data, or data, if you want to call it that. Now, descriptive statistics is organizing and summarizing data by graphing and by numerical values such as age. Okay, inferential statistics uses methods to take a result from a sample and extend it to a population and measure the reliability of the result. Okay, that's a really big idea in stats, is that we have a big population we want to know something about. But there's no way for us to get data from every single individual in this population. So we take a sample. Okay, this is our sample. And we analyze the sample, and we want to make conclusions about the sample that correctly reflect the population. This is called inferring. Okay, so inferential statistics are statistics we take from a sample that we make conclusions about a population from. Okay, you've heard of this. Probability is the chance of an event occurring. Here's another word for you. Population. You know this, but in this case it's the complete collection of all individuals that is to be studied. For instance, I could say all Richland High School students, or all registered voters. Okay, notice all is a key component for a population. Now, a sample is a subset. It's a sub-collection of the members of the population. For instance, if I just take RHS students, I could take seniors. Or all registered voters, I could take voters in Texas. Okay, that's a subset of the big population. Now, sampling is a practice of selecting a portion of the larger population and studying that portion to gain information about the population. The data are the result of the sampling from population. Great. Okay, now here's a key word. A parameter is a numerical measurement describing a characteristic of a population. For example, the average age of students enrolled as an undergraduate at Texas Women's is 21.1 years. Okay, you could have included all right here, all students, but the parameter is the average, and we have it very specifically 21.1 years. So it's an average of 21.1. That's the parameter. It's the measurement. Okay. Then a statistic is a numerical measurement describing a characteristic of a sample. Okay, it came from the sample. This measurement up here is all the students. This came from all. This came from some. So the average age of 500, okay, notice that's 500, not all, is selected at random is 20.3 years. So it's still an average of some, not all. Okay, that's what makes it a statistic. A parameter is from all. A statistic is from some. All right, let's try some of this. State elections of Texas. The comptroller, or the management level position responsible for supervising the quality of accounting and financial reporting of an organization of Texas, wants to know how she will do in the upcoming state election. She hires a consulting firm, and they polled 3,150 registered voters. The consulting firm finds that 57% of the polled voters will vote for her. It turns out that after the election, she wins 60% of the vote. Okay, so it says identify the parameter and the statistic, so the parameter. It's a measurement that reflects the population. Statistic is the measurement that reflects the sample. Okay, so let's look at this. She hires a consulting firm that polled 3,150 registered voters. Now, is that all the registered voters? No, that's from the sample. Okay, that's the total from the sample. The consulting firm found that 57% of the polled, where did that 57% come from? That's from the sample. Okay, because it's from the sample, that makes it a statistic. So my statistic is the 57%. Okay, now looking back, it turns out that after the election, she wins 60% of the vote. That 60% didn't come from just the registered voters. That came from all. That's the response from all the voters. Okay, because it's an all, that's the population. It comes from the population, which makes it a parameter. So 60% voted for her from the population, but from the sample, only 57 voted for her. Okay, so you're going to have to tear these things apart and look at the numbers and what do they reflect back to. Now, a representative sample is the idea that a sample must contain the characteristics of a population. One of the main concerns in the field of statistics is how accurately a statistic estimates a parameter. This is so crucial to this course, all right? So we have a variable. It's a characteristic or measurement that can be determined for each member of the population. Now, what kind of measurements do we take? We take a mean or the average, what you know of as the average, but we call it the mean in stats. Or we take a proportion. Okay, proportion is a part out of the whole. So I want you to think of a percent, x over 100, okay? Some percent of the population is brunette, or some percent of the population is male, okay? Something like that. So means and proportions are really important for you to distinguish in this course. All right, here's another example for us. Let's go back a little bit to population and sample. It's a little out of order, but let's do this. The research organization contacts 1,500 teenagers who are 13 to 17 and live in the U.S. and ask whether or not they have been prescribed medications for any mental disorders, such as depression and anxiety. So, look at this. 1,500 teenagers who are 13 to 17. All right, so I have 1,500. I have to decide, is that 1,500 a sample or is that the whole population? Well, hopefully you know that there's more than 1,500 teenagers out there. So this is my sample. So then I back up. What population does this 1,500 represent? It represents all 13 to 17-year-old teenagers. Okay? So more specifically, 13 to 17-year-old. Okay? So we break it down and distinguish. B, a quality control manager randomly selects 50 bottles of soda that were filled on October 15th to assess the calibration of the filling machine. So this 50 bottles of soda, you think that's all the bottles of soda they filled that day? Probably not. So the population and the sample. Well, the sample is the 50 bottles chosen. That's the sample. So the population would be all the bottles filled specifically on October 15th. All right. Farmer wants to learn about the weight of his soybean crop. He randomly selected 100 plants and weighed each soybean. So did he only have 100 plants? Probably not. So my sample is the 100 plants. But what is the population we're investigating? It is all his soybean crop. Okay? All his soybean crop. All right, example 3. Determine whether the underlined value is a parameter or a statistic. Again, more practice with this idea of parameter or statistic. Following the 2006 national midterm election, 18% of the governors of the 50 United States were female. Okay, so look at this. 18% of the governors of the 50. Well, how many governors do we have? We only have 50 governors. So the entire population is 50. And if 18% of them responded, that number came from the 50. Only 50 to have. Okay, so that's the whole population. Since it's the whole population, we call that the parameter. The average score of a class of 55 students taking a statistics midterm was 68%. Okay, if the whole class was 55, that's the population we're looking at. And their average was this. Because it came from the whole class, it is a parameter. So this is from all the students in that class. Okay. In a national survey of high school students, grades 9 to 12, 25% of the respondents reported that someone had offered them, sold, or given them an illegal drug on school property. All right, so here's a clue. In a national survey, does everyone respond to a survey? No. Okay, that survey creates a sample. From that sample, we get this 25% of them responded, right? Because that them refers back to the sample, that makes this a statistic. In a national survey on substance abuse, again, here's your survey, 66.4% of respondents who were full-time college students, age 8 to 22, reported using alcohol in the last month. So again, because it's the survey creates the sample, and we get this number from our sample. That makes it a statistic. E, only 12 men have walked on the moon. The average age of these men at the time of their moonwalks was 39 years, 11 months, and 15 days. Well, that's an average. How many men have walked on the moon? Only 12. So the whole population is 12 men. And the average came from the population, so that makes this a parameter. Okay. Telephone interviews of 1,433 adults, 18 and older, conducted nationwide March 2013, found that only 72% could identify the current vice president. Very, very sad. So, a telephone interview. Do you think everyone's answering their phone? No. The telephone interview is a survey method which creates a sample. It's not everybody, right? It's a sample only, and because it's coming from a sample, we know that this has to be a statistic. Okay? So it's important to read these questions and work your way through the logic. All right, keep on checking here. Now, determine whether each scenario is referring to a mean or a proportion. Again, an average or a percent. Okay, sorry, average or percent. That's what you have to decipher here. So, A, more than 30% of registered voters in Denton County voted in the primary election. Okay, it's a percent right here. It's your clue, right? So this is a proportion. B, we want to compare the heights of men to the heights of women. Well, when we compare height, we would take an average height, right? Logically, because it's an average, that means it's a means problem. In a recent poll, 73 out of 100 people said they access at least one social media account daily. Well, 73 out of 100, that's a portion of a whole, or 73%, okay, that makes it a proportion. All right, look at this. Males and females were asked about what they would do if they received the $100 bill by mail, addressed to their neighbor but wrongly delivered to them. Would they return it to their neighbor? Of the 69 males sampled, 52 said yes, and of the 131 females sampled, 120 said yes. So let's think through this. Males, there were 69 people talked to, 52 said yes. Females, there were 131 talked to and 120 said yes, okay? Well, either way, we're talking part of a whole, right? It's not an average, it's a part of a whole. So this creates proportions. All right, so that's the gist of this first lesson. There's a lot of vocabulary going on, parameters versus statistics, means and proportions, lots of little things to learn in here. So hang in there. It's a new topic for you, lots of vocab, but hopefully not too difficult. So we'll finish this lesson in class. Notice the notes, it says in class, so I will pick up here when we get to class.